Hello and welcome to another tutorial for Unity programming and developing games. For this particular tutorial, we're going to try to create an actual game. So far we've learned quite a lot of different techniques and coding principles and different ways of implementing little mechanics, so like movement mechanics and shooting mechanics and UI mechanics. And so I thought, let's not necessarily explore anything particularly new, but instead let's see, can we make a small game that actually runs, right? So we've actually got a start, a middle, and an end. So one of the things I was thinking about, okay, so we've learned how to make things spawn with our shooting first-person tutorial. We've learned how to make things move around with our character controller tutorials. And recently we've been doing some UI stuff. So I thought the game that most encapsulates probably these different elements as simply as possible that we can create. It's probably some sort of arcade game, so I was thinking we would have a bash at making a bullet hell game. So these games, bullet hells, you've maybe heard of. Basically, you have this 2D character that you're moving around, you're shooting bullets, your own bullets, across the screen, and then there's also these enemies that move into the play area and they shoot lots of bullets at you, and it's called bullet hell because there's all these bullets that you have to dodge. Let's see if I can find a particular section of this video. Here we go. So we've got, oh, look at all this stuff you have to dodge, my goodness. So we're going to try and implement stuff like that. I'm not sure if we'll get time to do bosses. We'll see what we can get done. So what I've done to start off with is I've just made a new 2D Unity project. First thing we're going to want to do is create our character. So again, some of these things are going to be familiar to you, so this will be sort of a faster tutorial. I'm not sure how many parts it will be, but we'll just see what kind of mechanics we can throw in and make an actual game, maybe with a high score and things like that. So I'm going to go ahead and right click and make a new 2D object sprite. So this is going to be our character, and we're going to need a sprite for our character. So to do this, I'm going to go ahead and use Piskel. It's a pretty cool free online sprite editor. You might have been shown it already. I'm just going to Google Piskel, and then whenever I get to the website Piskel, I'm going to go create sprite. We're going to create something really simple and really quick here, but again, for those of you who are a bit more artistically minded, you can make something that's really cool maybe. So I'm going to go ahead and make myself, what kind of character should we have in our bullet hell? I'll go for something pretty simple, like a big old spaceship. It looks like a horrible green triangle. Again, I'm just mostly focusing on the programming stuff, so like I could definitely spend some time making something that's cool. But for now, I just wanted to make something that's, maybe it looks awful. This does actually look pretty bad. But that's not the point, because you can spend however much time you want on this yourself. And I'm sure you can make something that's nicer. But I'm just here to teach you about your coding stuff, which is a little bit more tricky to get your head around. Alright, so I've made something that looks a bit like a spaceship. There we go. So I'm going to go ahead to export. I'm going to export as download here with PNG, download sprite sheet. So if it was multiple images as part of an animation, it would be imported as a one image with all of those different parts combined. So I'm going to go to my downloads. I'm going to go ahead and grab, and you can see, let me see, I can see the new image here in my downloads. So I'm going to go to my Unity. I'm going to go ahead and drag my new image into my assets folder. Because it's pixel art, we're going to go ahead and make sure we turn off our anti-aliasing and compression, which will make this really blurry. So I'm going to go to compression none, and this is on the image itself. And I'm going to go to filter mode by linear and change it to point and apply. So now we've got our image, we can go ahead to our sprite and drag our image into the sprite field variable of our sprite renderer, and there we go, our little ship has appeared. Now, I'm going to go ahead and click on this game view because my spaceship is really, really tiny, so I'm going to go ahead and make my spaceship a little larger by changing the scale. So I'm going to go 2, 2, 2, maybe 3, 3, 3. And then I'm going to position my spaceship over here. Maybe the background should be a different color from this default Unity blue, so I'm going to go ahead to my camera, change my solid color background to maybe like a space black or a gray. Usually I want to go solid black, so maybe like a bit more saturated. Or I'm not sure if that's the right word to describe that, but ultimately, we've got our near black, dark gray. All right, so we're going to start adding our controls. So this should be familiar with you. We're going to do player movement, add it as a new script. And I'm going to go ahead and open up this script, and we'll add movement. So I was thinking, our character could just move up and down. We could lock that to the axis, and then I thought that was maybe what we would do. But then actually, from watching these bullet hell videos of the games, I did notice actually that the characters in quite a lot of these games can actually move forward. Like you can see they're not really doing it there, but every so often they'll move sort of up into the screen like there to dodge bullets. So it's like a good idea to keep on one side of the screen, but sometimes you move up. So I think what we're going to do is we're going to have free movement. But we're going to try and clamp it so that the character can't move off the side of the screen. We just want it to be, moving within the boundaries of our screen. And then it'll just be a bad idea to move over here to the right side because that will be where all of the enemies are coming from. The other thing that we've been doing recently is for our character controls, we've been using a rigid 2D body. So I'm going to go ahead and make this here rigid 2D. And we've been adding a force to that maybe. But because we want our super snappy arcade movement style, we don't want it to be floaty. Look at how in this, I know this is just one game, but I'm sure I can find another game. The character basically just moves like exactly as you press the key. So if you press left, the character will move just consistently to the left. There's no gravity to the movement. There's no velocity or anything like that. So it's ultimately just really snappy. So what we can do is we can directly manipulate the velocity rather than adding force to move our character in a more snappy arcade manner. So I'm going to go ahead and use a public rigid body 2D. We're going to call this just body. And this is going to be our class variable with which we can access our rigid body. And then in our update, we're going to go ahead and ask for our input. So we're going to go ahead and use an if statement. If get, what is it? Input dot get key. And this is, I'm sure this is familiar to you by now. So we're going to go get key, and then within the argument for get key, it's going to be key code dot, let's say we'll start with W for going up. Got to make sure we have our curly brackets for the if statement. And then this time, instead of doing body dot add force, which we've maybe done before, we're going to just go ahead and directly change the velocity of our body. So we're going to start by storing that velocity as a new vector 3. I know it's in 2D, but in Unity, 2D is sort of fake. It's just like if I go back to my 3D view, you can sort of see it is actually in 3D space. It's all a bit strange. So we do still use Z positions for our objects, even though they shouldn't really use. So I'm going to zero out the Z position actually. But the point is, even though we're only using really the X and the Y, we still have to use the Z for our position. So we're going to use vector 3. It's going to be called new movement. So this is going to be made every frame. And we're going to say it's equal to a new vector 3. So every frame, we're going to create this new movement. We're going to calculate the new movement. And then at the end of our update, we're going to go ahead and set the body dot velocity to our new movement. And that means that this velocity will get completely overridden every frame, to the exact movements that we want. So now we just have to change our new movement every frame based on our input. So in this case, if we're holding down the W key, we're going to add to our new movement. So we're going to do plus equals instead of equals. We're going to add to our new movement vector 3, which is going to be to the, let's see, it's W. So we're going up. So we want it to be a new vector 3, 0 on the x-axis. We're going to say plus 1, which is just 1 on the y-axis, and then 0 on the z. So this is basically just up. We forgot to say new. So we're creating a new vector. Now we could do this with a vector variable instead of setting it in the code, but I'm just going to hard code it. That's fine. And now we're just going to do the same thing for each of our other inputs. So copy paste, copy paste, copy paste. It's going to be S for going down, and that's going to be -1 on the y-axis. We're going to do capital A for going left, which is going to be -1 on the x-axis, and let's get rid of this y-axis. And then for going to the right, we're going to go ahead and use D, and we're going to go ahead and make this a +1, and the y is 0. So now we've got all of our different directions and our velocity. The last thing we're going to want to do is we're going to want to multiply our new velocity by time dot delta time, and then also to offset that, because that's going to be really slow if we multiply by time dot delta time, because time delta time might be like 0.01 or something, right? So we're going to multiply it by our speed, and that's going to be a public float we'll make called speed. And that's all looking great. The last thing we're going to want to do is, because we're using a rigid body, for our movement, we're going to change this to fixed update so that it runs every physics frame, because that's whenever we actually move objects using rigid bodies, compared to update, which happens every frame, even if it's not a physics frame. So I'm going to run the game and see what happens. I always make the exact same mistake, which is I forget to drag my rigid body in. That's why it says unassigned reference exception. That's a classic one. The other thing I'm going to want to do, I've noticed that my character just falls out of the sky. And that's, well, they're falling very slowly now, but that's because of our gravity. So I'm going to go ahead to my gravity scale for rigid 2D. I'm going to turn that off to 0. So now my character does not fall. Alright, my character is moving around, and that's because I've yet again forgotten to set something up. I've forgotten that my speed is 0. So I'm going to go ahead and set my speed to 100. And I'm not going to spend too much time tweaking this, that's up to you. And that looks quite right, and hopefully you'll see that you've got this really snappy movement now. The moment I press D, they start moving at exactly the same speed, and whenever I release D, they'll move, they'll just stop moving, right? So we've got this sort of exact arcadey movement. Alright, so we've got our character moving. The last thing we want to do is clamp our character's movement so that they can't leave the screen. So one of the things we can do is we could create barriers so that they physically get blocked. But instead of using that, instead of like creating a wall basically, we can just make sure every time we move it that it's not allowed to move beyond certain values. So I'm going to move my character up to the top of our screen, and you can say that my y-axis value of the character is now 4.48, which is basically 4.5. And whenever I move down to the bottom screen, I wonder, is it a minus in the same direction? Yeah, it is. It's like 4.3. Which is sort of like 4.5. So I'm going to go ahead, and whenever I move my character every frame, we're just going to go ahead and grab a transform component, which is going to be the transform of this object that we're moving. So this is just going to be this object transform, and there's different ways of doing this, but we'll just do it this way with the variable. And now we're going to go ahead and set the position equal to the position, but this time we're going to clamp certain values. So what value we're going to clamp? Whenever I say clamp, that basically means restricting a value between a min and a max. So in this case, we've got we can create an x position. Let's do the y first of all, because we sort of calculated the y there, didn't we? So float y position, which is equal to this object.position dot y. And so what we can do is we can take our y position, and we can use this function called mathf dot clamp. And this is going to take 3 variables. It's going to take the current value, which is going to be our y position. It's going to say what's the minimum value it can be. And we work that out as being like minus 4.3, I think. Minus 4.3. And again, I'm hard coding this. You can turn this into a variable to change and tweak. And then the max value is just going to be 4.3 in the other direction. And I'm using f at the end to remind it that it's got a decimal point because it's a float value. And now this clamp is going to return a value which is either the max or the min if it hits the max or min, or just the current value that it already was. So now we're going to go ahead and say our y position is equal to this clamp that we've created. And we can do the same thing with our x position. So we're going to go ahead and make one that's for x. Then we're going to clamp our x position. What kind of values do we want here? So I'm going to move this over to the extreme edge, and we'll say that's like minus 8.3. So the minimum value that x can be is going to be minus 8.3. And the max is going to be, presumably going to be 8.3 on the maximum value. Yeah, so because 0 is right in the center of our screen, that's why it's sort of the negative and the plus value of the same thing. So we've got a much wider space to move in than we have a tall space, which matches up with the fact that we've got a horizontal horizontally aligned screen, right? So the last thing we want to do is, we've got these values, but now we need to slot them back in. So I'm going to go ahead and set my position, and it's going to be equal to a new vector 3 with these new values. So it's going to be with the first value is x, so it's going to be x position. The second value is y, so it's going to be y position. And the last value is z, which we need to set to 0. Z should always be 0. We're not using the z-axis at all. So if I start the game now, we've got another unassigned reference exception, and that's because the transform here is not set to anything. So I'm going to drag the transform of this object itself in there. One thing to note is whenever you copy something, make sure that you change all the values. For example, here I copied this y position and turned it into an x version. So I changed this to x, I changed this to x. Sometimes it's easy to forget, and you have y position is equal to, and then you clump y, but then you have x position, and maybe this is still y. That might be a problem. So if you're getting errors with the behavior, that might be something that you forgot to do. Something I often forget to do anyway. So I'm going to save and run it now and see what happens. So my character's moving around, seems normal enough. Let's see what happens if I try and move off the screen. Now my character just can't move higher than this 4.3, which looks about right. And let's see what happens if I try and move off the screen. I think my character might be moving too slowly for my bullet hell game. And yeah, so it looks like the boundaries are working. Let's go ahead and change the speed. I'm going to double it to 200 just so my character can move a bit faster. Yeah, I think this is better. So we've got a character that moves. We should probably move them back across here to the left-hand side. So we're starting our movement here. So the next thing we're going to do is we need something that will challenge the player, right? We need something that is going to be an enemy. So in these bullet hell games, quite often the enemies are shooting at you, or we've got these crazy bosses. But the main thing is we're essentially spawning things up at the top of the screen. Like here you can see these enemies are all coming down from the top of the screen, and then they're shooting at the player with projectiles. So let's start with that first step, which is spawning in our objects over time. So we're going to go ahead and go create empty. I'm going to call this our spawn manager. Spawning is maybe a concept you're already familiar with in games, where you basically are creating another instance of something. We've talked about instances before. So I'm going to call this our spawn manager, and we're going to make a spawn manager script as well. So now we've got a spawn manager script. I'm going to open this up. So the spawn manager is going to spawn something in every so often on the right-hand side of the screen. In this case, we need to create a game object, which is going to be a reference to the thing we're going to spawn in, which will be something like, let's start with a simple enemy prefab. So the enemy prefab is going to spawn in. When is it going to spawn it in? Well, we don't want it to spawn it in every single frame. We only want it to spawn it in with intervals. So I'm going to go ahead and create a timer. So this is going to be a float. Let's call it public float spawn timer, and this is going to spawn in every so often. And then we're also going to have a spawn time, which is the amount of time that the timer has to get to before it will spawn something new. So if the spawn timer starts, and we've done some timer stuff already, so if it starts an update, we're going to go ahead and plus equals time dot delta time, which means that as the game progresses, the spawn timer will count up. And then we're really just looking for when is that spawn timer going to spawn something in. So if it's greater than spawn time, then that means the amount of time has elapsed that we're checking for, and therefore we're going to spawn something in. And it's also important that we reset the timer. So I'm going to go ahead and reset my timer to 0. So I'm going to save now. We aren't actually spawning in anything at the moment, but I just want to see if the timer works. So I'm going to set my time to 1 second, let's say. And now this timer should hopefully count up to a second and then reset. You can see it never actually gets to 1, because the moment, the frame that it gets to 1, it's then immediately resetting. Like if I set it to 2, you'll see it increases to 2 and then resets. So once it gets to 1.9 or something, that'll probably be the closest we ever see it get to the value, and then it resets. So we're going to spawn something in every second for now. We can tweak that later, but let's actually get something spawning. So to get something spawning, we're going to have to make an enemy. So in this case, I'm just going to make something really simple in Pixel again. Just you can create your own version of this. Let's make it red, because red things are to be avoided. Red means danger. What should we have? We'll have like a kind of horrible spiky looking thing. I don't know. I'm doing this really quickly just so I can focus on the mechanics and the coding, but for your version you can focus on some of the art side of stuff as well. Oh my goodness, what am I making? It's horrible. Okay, and then I'm gonna fill it in. I don't even know what this is, but whatever. I'm gonna export it. Same thing, export it as a sprite. Gonna open up our downloads. We're gonna drag in this file into assets. We're gonna go ahead and set this to none, compression, point no filter for filter mode, and apply. And now we've got our enemy. And now we're gonna go ahead and create a new 2D sprite, drag our enemy onto the sprite variable. So we're going to set our scale to 3 again, just for now. You know, we can tweak with how big the scale. So we've got this thing to avoid. It looks like it's going to damage us, so we need to avoid it. So to create this, to make this an enemy that we can spawn in, we're going to turn it into a prefab. And we do that pretty simply. We're just going to go ahead and take our enemy that's an object in our scene, and we're going to drag it into our assets folder. And you can see now it's a prefab. We don't even need the original version in our scene. I'm going to delete that, because now we've got this version of the enemy, and if I double click you can see it here in our scene view, and we'll go back here with this back button back to our scene view of our overall. But basically we now have this prefab, which means in our spawn manager we're going to drag this prefab, whether it is enemy, we're going to drag that into our enemy prefab variable field, and now the script will know which enemy it is we're talking about when we talk about spawning, but we haven't actually spawned it in on the code. So to spawn in the object, we're going to have to know where it's going to spawn. So let's go ahead and move our spawn manager to roughly the edge of the screen here. In fact, I'm actually going to move it past the edge of the screen so that it will spawn off the screen and then move into view, rather than sort of appearing in midair. So we're going to move it across here, and then we're going to spawn it in. So whenever we spawn, we're going to grab our enemy prefab, and we're going to go ahead and make sure we have it inside this if statement, because we don't want it to spawn every frame. We only want it to spawn every second or so. I'm going to go ahead and use instantiate. And instantiate is a Unity specific thing, and it's going to take an argument of the prefab to create. We're creating an instance of that prefab. And then we can choose one of these versions which has a position as well. Actually, I'll just, let's see, yes. So the position of it should probably be the position of this. So we're going to go ahead and say, make a transform for the spawn position. So public transform, which is going to be like spawn pause. And then this will be what we use for our position. So spawn pause dot position. Doesn't like that. There's probably a version of this that I can use. So there's different versions of instantiate, and I can see the different versions by clicking, putting in the comment and then using the up and down arrow. You can see there's actually 10 versions of instantiate, and they each have slightly different arguments. In this case, I think this one looks good. We've got the original, we've got that's the thing to spawn, we've got the position, that's where it spawned. We just have to have a rotation. We don't want it to rotate any particular way, so I'm just going to go ahead and say quaternion.identity, which means no rotation at all. It's a really weird way of saying no rotation, but that's just how you get sort of the default rotation from the quaternion, which is a type of rotation. Identity means 0, 0, 0 for our rotation. Anyway, so now we're making a new version. We're spawning in our enemy. The only thing we need to do now is save, and then drag in our own transform of where we spawn. We can have a different object to choose where we're spawning, but for now we'll just double up and use the spawn manager itself as all the position for where to spawn this. So now every frame or not every frame, but every second our enemy is spawning in. Our enemy doesn't actually do anything at the moment, so we're going to make it move towards the player character. So let's go ahead and go to our enemy. We're going to add component enemy. So I'm going to go ahead and open up our enemy class. Here it is here. So what we want to do is move it across the screen. Let's just do that really simply by going ahead and, well, not even, let's see. No, let's just do the thing we did already. So we've got a rigid body. We're going to go ahead and make a rigid body class so that we can do the same thing, except this time we don't need to do all this crazy different stuff to try and get a different input. All we want to do is make our character move to the left. So in every fixed update frame, so we're going to change this to fixed update, we're just going to get our body, and we're going to set that to a velocity, which is equal to a new vector 3, and it's always going to be going to the left, right? So that's just -1, 0, 0. Because that's just going to the left, -1 on the x value. We don't want it moving up. We don't want anything in the z-axis at all for now. And then we just have to make sure that we multiply this by time.delta time. And we also multiply it by our speed. And we can set the speed here. Public float speed. And notice how I'm making these changes to the prefab and the asset itself, so that every time we spawn it in, it will have these differences. So we can go ahead and add the 2D rigid body. Or what was it? It's rigid body 2D or something like that, isn't it? There we go. Rigid body 2D. Drag it in, set the speed. Well, if our character moves at 200, then perhaps our enemy should move at like half that speed. So we'll put the speed of the enemy to 100. And now, hopefully, whenever we spawn in our enemies, it will just start moving across to the left. Interestingly, it's sort of like moving at a slight angle as well, which I'm not sure why that is. Is it because our enemy is rotated? No, our rotation is 0, 0, 0. Oh, I know why it is. It's because there's gravity on these projectiles, on these enemies. So they're falling as they move across. So I'm going to go ahead and go to my enemy and change the gravity scale of that to 0 as well. And now, hopefully, they should just move across the screen. Now, it's pretty easy to avoid these enemies at the moment. They're all in one big line. So let's change that and make them randomly spawn. And then we'll also make them appear at different heights. And then I think that might be us for this first part. And then in the second part, we can add some other gameplay mechanics. But we've got quite a lot already. Let's go ahead and randomize to some extent the position. So we do want to spawn at this position, but actually we want to go ahead and randomize it. So first, we're going to store it. Store the position in new random position, which is going to be equal to this. And then we'll use the new random position instead. So nothing's changed so far. We're just storing the position in a vector 3 temporarily. This is the position that it should spawn in. And then we're using that to spawn it in, so nothing should change. But now, in between these two lines, we can add a new random element to the y axis, because we want it to spawn between these two values. And it's the same as before, right? It's the same as our clamping, basically. Our player movement, we wanted to clamp between, on the y-axis, between -4.3 and 4.3. So I'm going to go ahead and add to our y. We're going to plus equals random.range. And random.range is going to take two arguments. It's going to take a minimum value between and a maximum value, and then it's going to return a random number between those two values. So the minimum is going to be our -4.3 that we already calculated from our clamping earlier, and then the maximum value will be 4.3. And now, because we add this random value to the y position, we're going to spawn in our object somewhere along the spectrum from the y to from the top to the bottom. There we go. This looks right. It just is very, very easy at the moment to dodge these. I know we don't have these in collision yet, but you know, imagining that we have to dodge these, it's still very, very easy. I think I might actually go ahead and make these really small. A little bit smaller. And this is sort of like more gameplay design stuff, right? So I'm going to make them scale to 2 instead of 3, but I'm going to have them spawn in every, let's say like every third of a second, so 0.3. And now let's have a look. So it should spawn in like an absolute colossal number of these. So this is looking a little bit better. I mean, it's still very easy to dodge. But for now, we've got gameplay, right? Ooh, I've got a good idea. What if it spawns in more and more as the game continues? Maybe we'll do that in part 2. For now, the last thing we want to do is actually make it that you have to dodge these things, right? So we need to add collision to our objects, and whenever they collide, it will be a game over. So I'm going to go ahead and add a component, which is going to be our circle collider. I think we'll use a circle collider. That seems like too big a circle because we'll hit things that we don't think we should hit. So I'm going to go and shade head and left mouse click on the radius of our circle collider for the character and bring it down. Yeah, that looks about right. 0.09 I have there. And then similarly, we're going to want to add a circle collider to our enemy. We could check for collision on the player, or we could check for collision on the enemy. I think we'll do it on the player, just in case the enemies collide with each other somehow in the future. So I'm going to go to my player movement, as well as our fixed update. We're going to go ahead and use this public void on trigger enter. But for on trigger enter to work, we're going to have to go back to actually to our I should change this from useSprite really. I should rename it to character. And we're going to change this circle collider to say is trigger is true. So now this is trigger will happen every time we collide with something, which will be the enemies. To be honest, I think we'll just destroy this. Actually, destroy game object. So the game object is basically just grabbing the object parent that this class is attached to, which is just going to be the character itself. So I can't spell destroy. There we go. So we're going to destroy the game object whenever we enter the enemy. So let's see, whenever we run the game, I'm going to go deliberately kamikaze into one of these. Nothing happens. No, there's no collision. Let's see what's going wrong. There's a circle collider on each of these. Let's pause the game. Each of these has a circle collider. I've got a circle collider with is trigger, but for some reason, on trigger enter isn't happening. Let me try and build the game and see what might be going wrong here. On trigger enter, we've got our trigger set to true on the character. One thing we're going to have to make sure is that our characters are on the same Z axis. So look, it looks like our character is colliding with these, but actually, because Unity is secretly in 3D, if I go to 3D view, you can see the characters are actually on a completely different plane here. And that's because my Y-axis, whenever I spawn in these objects, is out of whack. My spawn manager is spawning them in at its position, and for some reason I've set this to -7 on the Z-axis somehow, so I'm going to set this to 0, set our character to 0, make sure our enemy is set to 0. And whenever it spawns in, it should spawn in the same axis here, hopefully. Let's see, in the 3D view, it looks quite right. And now let's see what happens if I go into it. Still not colliding. I can check and see my Z-axis is 0 here. Is my Z-axis 0 here? Oh, I thought I'd fixed it. Rats. So why is it not colliding now, I wonder? We've got our collider. And we've got our collider here. What if I make the radius bigger? Still not colliding with anything. Well, if I turn on trigger to false, I'm just experimenting with random things here. This is sort of like doing debugging. If I set it to false, I can start pushing these stars around. This is quite funny looking. Look at my character spinning around. That's hilarious. So it's definitely colliding, right? But whenever I do is trigger, and I go to my player movement, for some reason this isn't happening. Or is it? I'm going to go ahead and debug.log. And we're going to debug.log, test to see, is this happening? Because if it is colliding but something else is going wrong, then we should see the log at the bottom left-hand corner. So the debug log isn't happening, so we're still not colliding for some reason. Does this work? I wonder if this works for you if you're working on it at the moment. Wonder why it's not colliding. I can't work it out.